The James Webb Space Telescope is a truly astonishing invention that will allow scientists to peer back in time and also gaze into the future. The telescope will allow us to view the origin of the universe by capturing the first galaxies that formed only a few 100 million years after the Big Bang. It seems that there is almost nothing this telescope can't do, and from the looks of the first image captured by the JWST, this statement rings true more than ever. So without any further ado, let's shed some light on the first images from the James Webb Telescope. Ever since its awe-instilling launch, the world has been collectively holding its breath to see the first images of the James Webb Telescope. And boy, is it a relief to have all our sci-fi fantasies come true. So what exactly is this telescope, and why is it so significant? The James Webb Space Telescope, or JWST for short, is a $10 billion space observatory launched on the 25th of December, 2021. It was named in honor of James E. Webb, an administrator at NASA during the 60s. The project began its development phase in 1996 and survived many delays and cost overruns, a ripped sunshield during a practice deployment, a threat by the U.S. Congress to cancel the project, and the COVID-19 pandemic itself. However, despite the obstacles, the telescope was finally launched, and as of April of this year, it is going under testing and alignment. Okay, so very recently, NASA released Webb's first in-focus image of a single bright star, which was successfully captured during the arduous mirror alignment process. Now, if you focus hard on the background of this image, you will realize that it is just a taster of what the telescope is actually capable of. Although many other alignment steps and tests need completing before Webb ultimately delivers its new view of the cosmos, taken from space, providing us with a tiny glimpse of how powerful Webb is. Although many other alignment steps and tests need completing before Webb ultimately delivers its new view of the cosmos, but the point stands that this fully focused image is the highest resolution infrared image that has ever been taken from space. It's absolutely astounding, and scientists couldn't be more thrilled because this is just a tiny fraction of the immense power that the Webb telescope possesses. Much of our current knowledge about cosmology and astronomy comes from the services rendered by the fabled Hubble telescope, which was launched back in 1990. The James Webb Telescope, which is considered to be a successor to the Hubble telescope, however, differs greatly from its predecessors on many accounts. For one, the Hubble telescope chiefly works in the range of visible light, from near ultraviolet range to near infrared range. The James Webb Telescope is operating in a range from red light to mid-infrared. One may wonder why such a choice was made, especially considering that the Hubble telescope has already given us some glorious images of the cosmos. There are three main reasons. 1. The primary goal of the JWST is to observe nebula, which are the birthplace of stars. Nebulas are much like a cloud, and to see through them, the most suitable modality would be infrared light. 2. To observe the first or oldest galaxies, whose light undergoes a shift from ultraviolet range to infrared range by the time it reaches Earth. It is necessary to have our observational equipment to operate in the same range. 3. To examine exoplanets, which are planets revolving around a star other than our Sun, and therefore are not a part of our solar system. In the infrared range, we can observe their atmosphere and its composition. That will not only help us discover more planets that may be feasible for human life, we may very well discover extraterrestrial life forms on these exoplanets, a prospect that was very much inconceivable with the technology available only a few decades ago. The James Webb Telescope also has a very interesting design. A primary mirror composed of 18 hexagonal segments made of beryllium and plated with gold gives us a diameter of 6.5 meters and an area of 25 square meters, which is 6 times more than the Hubble telescope. This allows for more light to be captured compared to the Hubble, and this would lead to images with better quality and resolution. The latest images from the telescope are very promising. Going back to the days of the Hubble launch, there was a critical flaw observed in the first image captured by it, and the telescope had to be repaired while it was in orbit. This would not have been possible for Webb, as its orbit is too far for such an operation. However, call it the hard work of the engineers or mere luck, The scientists at Baltimore in charge of analyzing the data, relayed by our new galactic telescope, are pleased with the results. So yeah, the James Webb Telescope will be providing us with a great view of the ancient galaxies in a not-so-far-off future, and we simply can't wait. Click on one of the 4 videos on the screen right now.